So, hi everyone. I am Anuj Kumar, Prime Minister Research Fellow, IIT Roorkee, and TA of this NPTEL course, Colloids and Surfaces. So, in this particular session, I will be discussing two problems which has been asked in the discussion forum, and followed by I will solving the assignment 8 of previous run. Okay. So, this is the particular question that has been asked in the discussion forum. So I will be uh, I have already discussed a little bit about this question in the previous video. So anyway, I will be solving it here in this session. Okay, so let's start. So consider an aqueous solution containing asymmetric electrolyte. So you are given asymmetric electrolytes, and it have the charge ratio of positive species to the negative species 3:2, and the concentration is zero point 0.1 molar concentration. Okay, so before solving this particular question, you have to just find the molecular formula of that electrolyte. If let's say I am writing here x y, and I am dissociating it x and y. Okay, and if consider it is, let's say it is NaCl. Okay, if you evaluate the total charge, that will be 0 here. Same in the case of asymmetric electrolyte, you have to just first you have to neutral the species. Okay, let me do that. So if I write here 2 and 3, so it will be dissociate like this. Okay, so if I see the z positive z negative ratio, it is 3 ratio 2. And if I see the neutrality of that electrolyte, uh, that will be it total charge will be 6, and similarly it will be -6, so that will be 0. So this formula will be the correct for this particular question. So you have to consider this type of electrolytes. Okay, the second point is you are given the concentration of this electrolyte. Okay, if you are having the zero point 0.1 molar concentration of this electrolyte, so if I talk about the positively charged species, it will be formed to its concentration will be zero point 0.2 molar, and similarly the negative charged species will have the concentration of zero point 0.3 molar. Okay, so these are the standard quantities you are provided here. So you have to calculate the debye huckel parameter in meter inverse, that is kappa value you have to find out. Okay, so let me just write the formula. That is k square epsilon square e square epsilon kbt multiply by this square. Okay, before solving the overall problem, I will be simplifying this. Okay, so temperature is given here 25, so you have to put the value of T is 298 Kelvin. So you have to focus basically on this part. Okay, so I am just writing the same thing again. This is zero point 0.1 molar, zero point 0.2 molar, and this is zero point 0.3 molar. Okay, if I am calculating the this value for x plus 3, it will be 1000, it's multiplied by its smaller concentration and the Avogadro number to find out basically the number per meter cube. Okay, so 1000 multiplied by zero point 0.2 and 6.023, 10 raised to 23. Okay, let me calculate it. 6.023, that is 1.20 10 raised to 26 per meter cube. And similarly, you have to calculate this value for this species. So you will getting zero point 0.3, this one, that is 1.806 10 raised to 26. Okay, if I calculate this term as a whole, that is just expanding it. So for the x positive plus 3 will be 1.2046 10 raised to 26. And what is the value of z? Uh, that is plus 3 square, plus similarly for negative spaces 1.806 10 raised to 26, and charge will be minus 2 square. Okay, so you will be getting, uh, if I take this term constant, it will be 1.2046 into 9 and plus 1.806 into 4. Okay, simple calculations. That will be 10.84 plus 4.806, 7.22. That is something like 18.06 10 raised to 26. Okay, so this value you can directly put here, and rest of the calculations uh, is very simple. You can solve similarly as I have solved in the some of the previous runs. Okay, epsilon r is given here, this value 78.54, and epsilon naught is 8.85 10 raised to minus 12. Okay, and the kb value is this. Temperature you have to put 298, and this term value will be 18.06 into 10 raised to 26. Okay, so it will be 2.56, 18.46, sorry, 18.06, 10 raised to minus 12. Okay, you can solve these calculations, and you will get something like the multiple of this 10 raised to 9, and you can put that value here. Okay, if it is clear, Then okay, I will go for the next question. Let me just confirm. Is it okay with you? Okay. And the second part of this particular question, you have to find the thickness of double layer in nanometer. So you are getting, let's say, if you are getting the value x here, okay. If you already have the value of x in meter inverse, okay, you can just revert it, and you will get 1 upon x 10 is to minus 9 meter, or 1 upon x nanometer, 1 upon k, or you can say k inverse, or you can say the thickness of double layer. Okay. Second part, you what you have to do is you have to just reverse the value and get the answer in nanometer. Okay, this is the question based on the Zeta potential. What is given here, the optical microscopy technique is used to measure the electrophoretic mobility. So electrophoretic mobility, what is the velocity per electric field, okay, of a dilute aqueous suspension containing these diameter amidine latex particles. These are I think the spherical particles. So this is the diameter, so radius will be 0.92 micron. Okay, the mobility data was calculated to Zeta potential using appropriate formula, whether it is using the Debye-Huckel model or Helmholtz-Smoluchowski model. So the Zeta potential of these particles as a function obtained through such a measurement is shown in figure 2. So this is the values that has been recorded, the Zeta potential as a function of pH. Okay. The monovalent chemical species used to adjust pH is this concentration is given here, and epsilon naught is 8.84. This is the standard values. Okay, so the relation is given here. This where Q is the charge on the particle, and is known apply for the case of spherical particles, with then the surface potential is low. Okay, uh, Rs is the radius of particle, the elementary charge is this. Okay, so based on the information provided here, you have to just, I think this is 10 is to minus 3 or 4 something in this question. Let me correct it. Okay, you can solve it accordingly. I am writing here 10 raised to minus 3 molar. Okay, so you have to, first question is you have to identify the pH above which the particles are negatively charged. Okay, so if you have to identify the charge, you have to just see the sign of Zeta potential value. So here you can see this is minus 20 and minus 40 and minus 60. Okay, you have to identify the pH above which the particles are negatively charged. Okay, let's say if it is 0 and I am just drawing a line, this is not actually a straight line. You can just use a scale, and you will getting something like greater than 11. Okay, because greater than 11 you will have the negatively charged eta potential. Okay, so 11, you can write the greater than 11, or you can say the 11.2, 11.5. In this particular range, you will be getting the negatively charged particles. So next question is the determine the isoelectric point from the plot. So what is the isoelectric point? at which the value of zeta potential is 0. Okay, so I have already drawn a line at so at this particular pH value, there will be the isoelectric point. That means if you are having the same concentration of positively and negatively charged species. Okay, and the third question, you have to calculate the surface charge Q at pH 11. From the figure, it appears that the zeta potential of the particle at pH 11 is 20 millivolt. So you are given this value, that is the zeta potential 20 millivolt, and you have to calculate the surface charge. Okay, if you see here, the relation is provided you provided to you, that is the Q. Let me write here, that is Q 4 pi epsilon eta, sorry, eta, and 1 plus kappa rs. Okay, so okay, let me expand this, 4 into 3.14, and epsilon will be the epsilon r and epsilon naught, and this zeta potential value 20 millivolt, you have to convert it into volt, and 1 plus k, and rs value is you have to give, you are given here, that is 0.92 microns, you have to convert into meters, that is minus 6. Okay, and the k value, before solving the charge expression, you have to calculate the k value using the same formula, that is this one. Okay, you have this value, you already have this value, and you are given this, both these values, and this is already known. You have to calculate just this by using what is given here, the concentration of the monovalent chemical species. So for example, you can consider the symmetric electrolyte having the monovalent species like NaCl. Okay, n plus and Cl minus, it will be dissociate like this, and if you are having the concentration of 10 raised to minus 3 molar, it will also be formed 10 raised to minus 3 molar, it will also have a concentration of 10 raised to minus 3 molar, and after that you have to calculate as usual this value, and how it is, that is 10 raised to minus 3, and multiply by Avogadro number. After that you have to add both the terms, these terms, and multiply by this z I square, so it will be 1 for both the species. Okay, after that you have to add this value for both the species, that is the sodium positive and chloride negative, or you can consider the monovalent xy. Okay, after that what you have to do is, you will be putting this value here, and you will getting the uh, value of kappa in meter inverse. Okay, after that, after getting the value of this kappa, you have to put that particular value here. Okay, and some terms will be cancel out, like say, if you are getting the x into 10 raised to power 9 meter inverse. Okay, so it will be okay, I am just rubbing. I will share the complete solutions. Okay, I am just giving you the brief idea how to solve this type of question. Okay, and this value is already given to you. Let's say I am putting this value here, that is x multiplied by 10 to power 9, 10 raised to minus 6. Okay, if it is a, so you will be getting x multiplied by 0.92, and okay, and after that uh, you will getting something like this. Okay, and similarly you will get the charge value in terms of 10 raised to minus 15. If you want me to solve this question, I will solve. Please type in the chat box. After that, I will solve the complete question. Or if you don't have any doubt, I will proceed for the next. Okay then. So the next question is, what is the zeta potential of of a particle that displays a mobility of 10 raised to minus 4 centimeter square per volt second? Okay, let me denote it by the electrophoretic mobility by U, V by E, velocity of the particle, that is 10 raised to minus 4 centimeter square per volt second. Okay, and the viscosity is given here, that is 0.001 pascal second. Okay, and a relative permittivity, that is epsilon r 18.4 and epsilon naught 8.84 10 raised to minus 12 coulomb square per newton meter square. Okay, so you have to assume the Debye-Hückel approximation here and solve this particular question. Okay, you say you have read two models: is electrophoretic mobility, C, this zeta potential, zeta and epsilon by eta. Okay, this constant value C is 2 by 3 for kappa r is less than zero point 0.1, and uh, so this is called the Debye-Hückel approximation. And in Helmholtz-Smoluchowski model, uh, this C value is 1. That is valid for this condition. Okay, so in this particular question, you are given the Debye-Hückel approximation. So what you have to do is you have to consider this value. Okay, let me write here. This is electrophoretic mobility. Okay, it will be 2 by 3, and zeta potential, the epsilon r epsilon naught eta. Okay, and the zeta is equal to uh, 3 eta u divided by 2 epsilon r epsilon naught. Okay, so the viscosity value you are given 0.001, and the electrophoretic mobility is 10 raised to minus 4. Okay, centimeter square. You have to convert it into meter. That will be 10 raised to minus 4 meter square, so per volt second. Okay, and multiply by this 2, and epsilon r, it is 80.4, and epsilon naught is 8.85 10 raised to minus 12. Okay, so this will be 1.5 into 80.48.85. Okay, point 0.001, and it will be something like this. Okay, let me solve this. Divide by 80.4 divided by 8.85. That will be 2.10 and 10 raised to minus 6. Okay, and 10 raised to 4. Okay, and it will be 2.10 10 raised to minus 2. That will be 0.0210 volt, or you can convert into millivolt. It will be 21 millivolt. Okay, so you have to report your answers in a millivolt, so you will be getting 20 millivolt. Okay, if it was the another model, so you have to just put these values for this particular expression. Okay, here for you y 10 is to 4. Okay, because here the value is given in centimeter inverse, centimeter square. You have to convert in meter, because all the terms, all the units are in mks. So you have to just, what you have to do is 10 raised to minus 2 meter square, that will be 10 raised to minus 4 meter square. Okay, okay. So I am going the next question, which is also from the discussion forum one has posted in. Okay, so here what is given here, the surfactant molecules in the solution for micelles above a particular concentration called the CMC. Okay, and the number of surfactant molecules in a single micelle is also terms the aggregation number. In an experiment, the radius of the sodium 2 decyl sulfates micelles R is found to be uh, this value, the radius, by light scattering method, whether it is SLS, DLS, and in order to measure the zeta potential or dispersion of micelles, this concentration is considered, and it is also found that the zeta potential of the micelle is 92.3 millivolt. Okay, assuming that the surface charge can be approximated by this expression, you have to calculate these quantities. Okay, ignore this value. Okay, so first I will be starting from the k value. As usual, we have to write this formula, that is summation. Okay, the temperature is 25, so T is 298. So try it by your own. I will be just asking for the value of kappa. Okay, accordingly I will be solving the other problems, that is 13, 14, 15, and 16. So first you have to calculate the kappa value at your own, because I have calculated kappa value multiple times. Okay, just I will wait for 5 minutes. Just calculate the kappa value and get me the answer. Try to solve it by your own, please. Temperature is given here. Everything is given here. Concentration is 0.01 molar. NaCl, symmetric electrolyte is given, and Z to Z ratio is 1 to 1. So please try to calculate kappa value. I will be waiting for your response. And it should be multiple of 10 raised to 8. Let me know if you are solving. Okay. Have you not solved till now? I am getting this value approx. Value of and z. Okay, let me solve it. I got 12 0 point. Yes, it is okay. I have also wrote the same thing here. You can see 12.046 into 10 is to 24. Okay, just you can check the calculation later. Okay, so I am going for the next part. Uh, okay, I'm going to the next part. That is, you have to calculate the surface charge. Okay, the expression is already given here. That is Q is equal to 4 pi this and the zeta r 1 plus kr. Okay, before putting the value, you have to calculate. You have to convert it into meter. You will be getting 22.110 raised to minus 10 meter. Okay, and similarly for zeta potential, 92.3 millivolt. You have to convert it into minus 3 volt. Okay, and put all the values here. Okay, just do the calculation and uh, tell me the answer for this. It will be something approx 3.0610 raised to power 80. You can check the calculations. Okay, minus 80. 12, 3, 25. Yes. Okay. And in the third part, you have to report the surface charge density. Okay, for surface charge density, let's say it is sigma star, and you have this value of total charge, and you have to divide by the area, that is 4 pi r square for spherical particles. Okay, you will getting the uh, surface charge density in coulomb per meter square, and after that you have to convert into microcoulomb per meter square. Sorry, you have to report in the coulomb per meter square. No need for this conversion. Okay, after that you have to calculate the number of charged surface on the particle surface. Okay, what you have to do, because in the total surface charge is equal to the number of dissociated groups multiply by 1.610 is to minus 19. Okay, and from this value you have the total charge value, that is 3.0610 raised to minus 18. If you divide by 1.610 raised to minus 19, you will be getting the number of these charged groups on the surface. Okay, let me try this. This is 3.06 divided by 1.6, that is 1.91, and 10 raised to 1. Okay, it will be 19.1. The dissociated surface functional groups are there. Okay, and the last question, that is, if you assume that only 20 percentage of molecules on the surface of the micelles are dissociated, and calculate the aggregation number. Okay, and what is the aggregation number? That is number of surfactant, total number of surfactant molecules in a single micelles. Okay, so this value is the equivalent to 20% part. Okay, for calculating the total number of molecules per particles, yeah, total number of surfactant molecules in a micelle, what you have to do is multiply 19.1 multiply by, this is 20%, for total value you have to convert it 100 divided by 20, because you have to back calculate. Okay, so the complete value will be 19.1 into 5, 95.5. This will be the aggregation number. Okay, so this is end of this session. If you have any doubt, uh, type in the chat box. Otherwise, I will be leaving the meeting. Thanks for attending the session. Okay, I'm waiting for your response. Okay, thank you. And I think everything in the session is clear to you. Okay, and this was the last session, I think, for this particular course. So thank you very much for attending. Thank you again. Okay, now I will be leaving the meeting. Bye bye.